Hey everyone, today I'm showcasing one of my commission projects, a full 3D scan of a 4,500 square meter warehouse spread across 4 floors. The scan data will be used to calculate the building's floor load bearing strength. For this stage of the project, my role is focused on capturing the 3D scans and building out the CAD model of the structure. This building measures about 60 meters long and 20 meters wide, with a staircase at both ends. To create a proper slam loop, the best approach is to start on the second floor and move between each level in looping path like this, and scan the roof deck separately using the RTK. In reality, staircase A was blocked on 2 floors, which forced me to take an incorrect approach. I asked the owner to unblock the staircase, but they refused. That means the floor level accuracy has to rely entirely on the device itself, the measured floor-to-floor height, and the number of obstructions present in the scene. Looking at the floor plan, you can see how much inventory is stacked up, leaving only a small portion of the floor slab exposed for scanning. On the second floor, less than half of the total floor area was actually captured. But the SHARE S20 has a LiDAR sensor tilted at 25 degrees, which allows it to capture all of the underfloor area. That's enough detail to verify both the position and the size of the structural element. If there is no inventory or obstructions, the best way to scan a large open floor area is by walking in multiple loops like this. Since SHARE uses a multi-slam algorithm, the more loops you close, the less drift you will see in the data. But in reality, I was forced to walk the scan incorrectly like this. If I had asked the owner to clear out their inventory just for the 3D scan, they would have fired me on the spot. So this project ended up relying entirely on the S20's tracking performance and SHARE's SLAM mapping capability. And that's when my luck really ran out while trying to scan the roof deck with RTK. The N-trip network went down. You can't see it in the RTK status. It kept jumping back and forth between single and fixed solutions, which confirms the network failure. As a result, this entire scan had to rely solely on the slam loop. Alright, let's move on to the 3D scanning. I'm starting on the ground floor, and it's important to face the scanner toward a clear feature during initialization. When the room is too small, like this one, don't go all the way in. Just reach in with a scanner for a few seconds, then back out. Whenever you enter a narrow space, always keep the scanner pointed toward the larger area. So in this situation, walking backward is actually pretty normal. And when you walk into a narrow dead end, just back out the same way. Avoid turning yourself around while standing still. And here is the cargo elevator. It's too small, so I won't be going inside. The parallel alignment between floor levels depends entirely on staircase tracking, so make sure to walk and turn slowly when moving on the stairs. As you can see, this warehouse is packed with inventory, and most of the LiDAR line of sight is blocked. This is one of the most extreme conditions you can put a SLAM LiDAR through. If the warehouse were clear, I would be using the lighter C1 instead. but in this situation, I need the best IMU I can get, so the S20 is the right choice. What about other measuring devices? With this level of blockage, terrestrial LiDAR won't work at all, and the same goes for a total station. Typically, the engineering team would bring 5 or 6 staff and use the measuring tape to collect data, but in this warehouse, that would be extremely difficult because the layout isn't rectangular. It's already been almost 15 minutes. The scanning process is taking longer than I expected. And here is the critical part, the transition to the roof deck. This is the point where rotational drift can easily be introduced. Because when you walk out from the staircase onto the roof deck, there are no walls or ceilings left for the LiDAR to track. That's why I usually scan this part of the building separately. But since the client will only block the ground floor load for 10 minutes, I have to make the most of the time I'm given, and as you can see, I'm already stretching beyond that. As I look back, I noticed my current trajectory was far from the previous one. Honestly, I was about 70% sure that SHARE SLAM would fail during processing, and I would have to rescan floor by floor, but to my surprise it held up and didn't fail. The total scanning time came to 24 minutes with a travel distance of 928 meters. The starting point and the ending point end up more than 5 meters apart. And here is the result. Even under these extreme conditions, the SHARE S20 managed to keep the first, second and third floor levels perfectly aligned. The roof deck floor is slightly tilted, but that is expected. Roof decks should always be scanned separately. I extracted the roof deck floor height from the staircase exit point since that location has no rotational drift. The beam center lines were then created in BricsCAD. The engineering team is quite satisfied with the output from the LiDAR scanner. In BricsCAD, I cropped the underfloor and identify the columns and beams directly from the underfloor point cloud. Then I use the beam functions to generate the columns and beam. The client's engineering team requires the output in Autodesk Rivet format so they can export the structural model into Autodesk Robot for simulation. Since I don't have Rivet, I will build the model using BricsCAD beam functions and then save it as an RVT file. Structural modeling is much easier than architectural modeling, yet the pay rate is about the same. I started this project at 10 a.m. spent 25 minutes scanning, an hour driving, and was able to deliver the drawings to the client by 3 p.m. A job this straightforward don't come along often, and I think the SHARE S20 performed impressively even under these harsh conditions. Alright, thanks you guys for watching. I'll see you in the next video.